This lecture is about the smoothing of language models. In this lecture, we're going to continue talking about the probabilistic retrieval model. In particular, we're going to talk about the smoothing of language model in the query likelihood retrieval method. So you have seen this slide from the previous lecture. This is the ranking function based on the query likelihood. Here we assumed the independence of generating each query word. And the formula would look like the following, where we take a sum over all the query words, and inside the sum there is a log of probability of a word given by the document or document language model. So the main task now is to estimate this document language model. As we said before, different methods for estimating this model would lead to different retrieval functions. So in this lecture, we're going to look into this in more detail. So how do we estimate this language model? Well, the obvious choice would be the maximum likelihood estimator that we have seen before, and that is we're going to normalize the word frequencies in the document. And the estimated probability would look like this. This is a step function here, which means all the words that have the same frequency count will have identical probability. Right? This is another frequency count that has a different probability. Note that for words that have not occurred in the document here, they all have zero probability. So we know this is just like the model that we assumed earlier in the lecture, where we assume that the user would sample a word from the document to formulate the query. And there's no chance of sampling any word that's not in the document. And we know that's not good. So how do we improve this? Well, in order to assign a non-zero probability to words that have not been observed in the document, we would have to take away some probability mass from the words that are observed in the document. So for example, here we have to take away some probability mass because we need some extra probability mass for the unseen words. Otherwise, they won't sum to 1. So all these probabilities must sum to 1. So to make this transformation and to improve the maximum likelihood estimator by assigning non-zero probabilities to words that are not observed in the data, we have to do smoothing. And smoothing has to do with improving the estimate by considering the possibility that if the author had been asked to write more words for the document, the author might have written other words. If you think about this fact, then a smooth language model would be a more accurate representation of the actual topic. Imagine you have seen an abstract of a research article. Let's say this document is the abstract, right? If we assume unseen words in this abstract, we have a probability of 0. That would mean there's no chance of sampling a word outside the abstract to formulate the query. But imagine a user who is interested in the topic of this abstract. The user might actually choose a word that's not in the abstract to use as a query. So obviously, if we had asked this author to write more, the author would have written the full text of that article. So smoothing of the language model is an attempt to try to recover the model for the whole article. And then, of course, we don't have really knowledge about any words that are not observed in the abstract. So that's why smoothing is actually a tricky problem. So let's talk a little bit more about how to smooth a language model. And the key question here is what probability should be assigned to those unseen words. Right? And there are many different ways of doing that. One idea here that's very useful for retrieval is let the probability of an unseen word be proportional to its probability given by a reference language model. That means if you don't observe the word in the data set, we're going to assume that its probability is kind of governed by another reference language model that we will construct. It will tell us which unseen words will have likely a higher probability. In the case of retrieval, a natural choice would be to take the collection language model as the reference language model. That is to say, if we don't observe a word in the document, we're going to assume that the probability of this word would be proportional to the probability of the word in the whole collection. So more formally, we'll be estimating the probability of a word given a document as follows. If the word is seen in the document, then the probability would be a discounted maximum likelihood estimate, P sub seen here. Otherwise, if the word is not seen in the document, we're going to let the probability be proportional to the probability of the word in the collection. And here the coefficient alpha is to control the amount of probability mass that we assign to unseen words. Obviously, all these probabilities must sum to 1, so alpha sub d is constrained in some way. So what if we plug in this smoothing formula into our query likelihood ranking function? This is what we will get. In this formula, you can see we have this as a sum over all the query words. And note that we have written it in the form of a sum over all the vocabulary. You can see here, this is a sum over all the words in the vocabulary. But note that we have a count of the word in the query. So in effect, we are just taking a sum of query words. All right, this is now a common way that we will use because of its convenience in some transformations. So this is, as I said, this is a sum over all the query words. In our smoothing method, we assume that the words that are not observed in the document will have a somewhat different form of probability, namely its form, this form. So we're going to then decompose this sum into two parts. One sum is over all the query words that are matched in the document. That means in this sum, all the words have a non-zero probability in the document. Sorry, it's the non-zero count of the word in the document. They all occurred in the document. And they also have to, of course, have a non-zero count in the query. So these are the words that are matched. These are the query words that are matched in the document. On the other hand, in this sum, we are taking a sum over all the words that are not, all the query words that are not matched in the document. Right? So they occur in the query due to this term, but they don't occur in the document. In this case, these words have this probability because of our assumption about the smoothing. Note that here, these seen words have a different probability. Now we can go further by rewriting the second sum as a difference of two other sums. Basically, the first sum is actually a sum over all the query words. Now we know that the original sum is not over all the query words. This is over all the query words that are not matched in the document. So here we pretend that they are actually over all the query words. So we take a sum over all the query words. Obviously, this sum has extra terms that are not in this sum. Because here we're taking sum over all the query words. There, it's not matched in the document. So in order to make them equal, we'll have to then subtract another sum here. And this is the sum over all the query words that are matched in the document. And this makes sense because here we're considering all query words, and then we subtract the query words that are matched in the document. And that would give us the query words that are not matched in the document. And this is almost a reverse process of the first step here. Right? And you might wonder, why do we want to do that? Well, that's because if we do this, then we have different forms of terms inside these sums. So now you can see in this sum, we have all the words matched, query words matched in the document with this kind of terms. Here we have another sum over the same set of terms, matched query terms in document, but inside the sum it's different. But these two sums can clearly be merged. So if we do that, we'll get another form of the formula that looks like the following at the bottom here. And note that this is a very interesting formula, because here we combined these two, that our sum over the query words matched in the document, into one sum here. And the other sum now is decomposed into two parts. And these two parts look much simpler, just because these are the probabilities of unseen words. Now this formula is very interesting, because you can see the sum is now over all the matched query terms. And just like in the vector space model, we take a sum of terms that are in the intersection of query vector and the document vector. So it already looks a little bit like the vector space model. In fact, there is even more similarity here, as we explain on this slide.